All right, finally, we are now evaluating our model on the test set, and we try to measure the so-called generalization error or prediction error with the coefficient of determination and also the root mean squared error. And finally, we try to find some more intuitive metrics for the accuracy of our model. And we have still saved our fitted regression object here, our random forest regressor. And first of all, we can get the coefficient of determination r squared. And now we pass our test set. So we pass x test and y test. And actually, it's no surprise that when using the test set, we get a lower r squared of 0.825, which is actually not too bad. And now in the next step, let's predict the labels for our test set. So we pass the features of our test set to the predict method. And we save the predicted house values in the variable pred. And based on the predicted values and the actual values, we can actually measure the mean squared error and also the root mean squared error. So before with our training set, we had, let me have a look, 18,000. So it should be higher here, but let's have a look. And here we get 47,000. So for beginners, these metrics might not be really intuitive, and therefore let's simply compare the predicted values with the true values. And we create here a new data frame, the compare data frame. And here we have all observations of the test set. So in total over 4,000. And we have the true house prices and the predicted house prices. And already here we can see that for some observations or for some districts, the difference is pretty high. So in the very first case here, we have the true value, the true median house price of 101,000. And actually the predicted value is 225,000. And also in the next example, the true value is over 200,000 and the predicted value is only 130,000. And we can also calculate the difference between predicted and true values, so the numerical absolute difference. And we can also calculate the mean absolute difference. So on average, we can expect that there's a difference of over 30,000 between the predicted value and the actual value. All right, thanks for watching, and see you also in the next lecture. Bye. We have created a good, but of course not perfect model, and let's gain some more insight. The conclusion of the explanatory data analysis was that the income might be the most important factor, followed by the location. And actually good news is that the random forest regressor can give us the relative importance of features for the model with feature importances. So let's run it here. And here we get a NumPy array. And actually, let's create a panda series and add also the feature names that we can extract from XTrain. So we get the column labels. And also we sort the feature importances from high to low. So let's run the cell here and let's save the result in the variable feature importances. Let's have a look here. And it's best to just visualize it. So we create a horizontal bar plot. And here we can see the importance, and they sum up to 1. And it's no surprise that the median income is the feature with the highest importance. Then we have inland or not, so that's the location. Then we have two features indicating the size of the houses. And then again, we have the location, so we have longitude and latitude. Next, rooms per household is an indicator of the house size. Then we have the median age. And finally, we have features indicating the size of the district, so those 4. And finally, we have, again, some location features that are not really important. So we can conclude that the question is whether the district is in the inland or near the ocean. And it doesn't really matter whether it is less than 1 hour to the ocean, near bay or island. And actually, based on this outcome, we could drop some features and rerun our model. But we won't do this now. And of course, you can do this as a homework. All right. Thanks for watching, and see you also in the next lecture. Bye.